from a company which is from Zagreb. It's called Ekobit, and we have a solution for data masking or data anonymization. I will be talking about this problem, data anonymization, and what it's for. And my background is, well, I have around 20 years of experience in IT. I started my career as a software developer, working for one of the biggest banks in Croatia. And back then, we were using production data, like copies. So we had a test and staging environment where, name of person or account number or credit card number was the real one. So it was actual data that we were using on a daily basis. Everyone knew that it was a bad practice back then, but today it's even, written in laws and regulations, and we are definitely not allowed to do that. And when all this started, so last year we were in some sort of panic mode in Croatia. Lots of people started, last minute accepting different practices, tried to stop using production data, and figured that it's not so easy. So a lot of people felt like cat 8-hour data. I don't know what to use. If I'm not allowed to use production data, what then? And the solution comes in the form of data anonymization or data masking. So GDPR, and I think similar regulation exists in Serbia as well, explicitly states that anonymization, so the practice when you change data in a way that there is no more actual names, no more actual account numbers, but there is something different, helps. So if you have a copy of a production database and you do some obfuscation on it, then you are good to go. This copy, obfuscated copy, doesn't have to be protected the same way as production data. So it's kind of legal now. It's explicitly stated that it's okay to do it in that way. The problem is that even if you change names or account numbers, changes could still be identified. It's not so easy to do anonymization properly, because when you see people like this, you can still make some assumptions about who could that be if you have context information. So if you know my height, or if you know my shoulders or something, or if you know that I was there at a certain time, you could still identify me between those three. So the challenge is to do it properly, the challenge is to do it well. And this is what people or companies generally do. So we start with production clones. This was like 20 years ago, for some people still what they do today. And most of them start by underestimating the effort needed to do data masking properly. So people start writing scripts. They say, okay, let's write a simple script which will just change names to something else. We will target specifically vulnerable groups, like for example employees of the bank. So we don't want other people to see their salaries, so we will mask them first, and then later on we will change something else, and so on and so on. This is, maybe even worse than not doing masking at all, because if you do masking, if you don't do masking at all, you will probably invest a lot in protecting your testing environments, because they contain the production data. They contain sensitive, personally identifiable information. So if you do masking poorly, this is extremely risky, because you could start with assumption, okay, our sensitive data is masked, but it's actually not. So it's even worse than not doing masking at all. And what we try to do with our solution, it's called BizDataX, is we try to do masking right. So we start from the very beginning. We say you have hundreds and sometimes even thousands of tables, and there is no single person who could possibly know where sensitive data is stored in those tables. For example, it could be a customer table containing first name and last name, But it could be also some transaction description containing same sensitive information, and no one would assume that it's really there. So we start with the discovery process and then continue on. To be able to show you how it works, I will introduce in this presentation the simple model. So I will assume that we have a database which contains information about customers, accounts, transactions, and credit cards. It's a simple model, very simple compared to what we deal with in real life, but it's complex enough and enables me to explain the basic principle. So if we talk about relational databases, the model could look something like this. So we have several tables. This is the first step. We have to identify the structure. So 5 tables in this case. Customer table, for example, account table, we see some columns. Everything about these tables is probably written in relational database. So if you have a tool which is capable of importing data from metadata tables in a relational database, you would probably get information like this. But not every field in this model is equally important when you take a look from data masking standpoint. For example, it's important to identify that customer ID is something special. It's a foreign key constraint, probably written in the database as well, and it connects customer table and account table. Similar applies for account ID, which could appear on both sides of the transaction, or something completely different. First name, last name. This data in my model appears in customers table and also in credit card table. In this case, it's different because we know this is definitely sensitive information, and also we could assume that there is no foreign key constraint or anything similar that we could use to identify automatically that there is some sort of relationship between those two. So when a software architect or database expert takes a look, he could assume this is data that has to be masked or changed somehow in sync, but generally speaking, it's not written in the database, so this is a little bit different. And also, we could easily assume that we could, establish this connection over customer ID, even though there is no link in the form of foreign key constraint. Okay, and the last thing, extremely important, you usually have multiple systems. So, typical bank would have core banking system, then some satellite systems, maybe 10, maybe 20, maybe 70 of them. Then there would be, like more models like this, and you have to, figure out the connections between data across. When we work with credit card processors, sometimes they have files like CSV or positional files containing sensitive information. For example, when they get exports of transaction data from point of sale terminals, and if they wanted to test processing of those files, they would probably want a masking process that could mask database data and somehow in sync file data as well. And this is the big challenge that has to be dealt with. Scripts cannot do that, tools like ours can. And I have prepared a demo and wanted to show you some hands-on screenshots and stuff about how it works. You can stop me at any moment, ask questions, and also we have a booth here, like 50 meters from this room. Come and visit us, and I can show you a whole lot more than just masking and identifying first name, last name, and such. So the resolution is so. Can you see anything? No. It's a little bit blurred because the resolution here is something like 800 pixels. So okay, let me explain it despite that obstacle. So Biz data tags, our tool starts with web user interface, and we have a concept of project there. This is, like a container, like a folder where you can store information about where sensitive data is, what type of sensitive data is that, what needs to be done to mask it. So the first step would be you have to import information about the data source. This is the point where our system connects to a relational database, for example, and gathers information about tables, columns, and such. Yes?
Any limitation about the database type? Which database can be accessed?
Well, do you have any specific database that you would like me to
No,
give
just
information
the
about?
Oracle, let you know what.
So it's any major database, like for example Oracle, DB2, MS SQL, MySQL, lots of databases are supported out of the box. But also we have a layer between, so we can make adapters for something, like REST API, which would make it appear to be like something like tabular. Also, if you have a specific question or would like me to give you a precise answer if certain database is supported, I would suggest that you visit us and we can discuss it. So when this process is done, you get information about, for example, customer table. There is like 7 columns or 10, I don't know, about data types and everything that could be imported from the database model itself. And then starts what we call a discovery. Discovery is here in menu options. So this is where you define the rules. Like for example, I can assume that my database somewhere contains names. And you choose an algorithm, like first name algorithm. You provide some parameters to that, like I want to search for US names. And our tool can then connect to your database, take random samples of, let's say, 10,000 records from every table, and compare values from that sample with a list of US names. And when this is done, you get information about probability that some field in the database contains first names. So the result is in the form of hit rate. So if you get a column which in 100% of sample records contains something that looks like US first name, hit rate would be 100%. And this is what you have to visit then. So status at this point is marked as unknown, and then you can check the data. If it's 100%, you can mark it as, now it's definitely first name field and so on and so on. So this is a combination of automated process. So tool helps you to define which columns contain sensitive data and which do not. So let me just let me show you how it works. So for example, if you wanted to visit a certain column, you could take a peek at data. This is the first name field of customer's table. There are names inside. Everything marked in red are values found in that column that are also found in list of first names. And by doing that, we can mark this one as sensitive. Continue working on it. Take a look at email address. As you can see here, email address also contains first name. So we say, okay, we have to mask email address column as well. And at the end of the day, we end up in a situation where fields like first name, last name, email address are properly classified. A typical project starts with like 1,000 tables, sometimes even 5,000 tables. A typical bank would have like 100, maybe even 200,000 columns. And with this automated process, we end up with a filter where we know that, for example, first name could appear in around 200 columns. Then you have to check and visit them manually and mark them, okay, this with 100% is definitely first name field, something with 25% like city in this demo is not, and so on and so on. So the tool helps you a lot to do this analysis and search systematically, and also helps you to produce structured results. And we call these structured results specifications. So I can filter to view only sensitive information, only stuff that was marked in red, and I can go and visit, sensitive fields and write something like, okay, this field, first name in customer's table, has to be masked in a way that we choose random value from list of first names. Same field in credit card table needs to be masked so that it is, again, random, but in sync with the first table. Email address will probably have to be masked in a way that we use masked value of first name, then dot, then masked value of last name, and then do some suffix so that it looks like email address, and so on and so on. So you can write these annotations. This usually works as a cooperation between a consultant who knows how to use our tool and someone in your organization who knows a little bit about your data or your applications. And the end of all this is a nice specification, like a list of schemas, tables, columns, and processes or algorithms that need to be applied in order to mask it. Any questions at this point? Has anyone tried anything like this, like sensitive data discovery? You did?
No, I have a question.
Oh, okay.
Do I need to mask all database, or I can limit the number of customers that I want to extract from database and mask them as a testing or development purposes?
Yes, you can, that would be called data subsetting. So what people typically do, people typically mask the whole master data set, but limit the amount of transactions that are masked. For example, if you have 10 years of transactions in production system, you probably don't need 10 years to be able to do some testing. So you would probably decide to discard the transactions that are older than 2 years from today or something like that. So we call this feature data subsetting, and yes, it's an important thing. And then we go to the implementation itself. This is where we actually implement these rules. So we call this part of our solution designer. We have algorithms on the left, and this is a set of rules that is a combination of those algorithms. So first name, you just drag and drop it, you have lists of first names. Last names, you have lists of last names. If you have streets, you would probably want to use streets, postal numbers, zip codes, credit card algorithms. So we have a lot of things in the toolbox, and you, table by table, apply those algorithms and prepare what we call a set of rules for a package. And when this package is defined, you test it, you run it several times on top of your database, and then you publish this and make it available for people to be able to use it on, let's say, weekly or monthly basis. So whenever someone wants to publish, wants to refresh a test environment or staging environment, they could, in addition to using standard process like backup plus restore, they would also run this final step of executing data masking rules. This is how it works. So this workflow here that we have created with rules changes names and customer table is conditioned to be able to mask male names differently than female names. Last names are typical US last names, and email address is a combination of first name plus last name plus some suffix so that it looks like an email address. When execution is triggered, it works like so you can have multiple packages. So you were asking, can you do only the subset? So you would have two packages, one that does subsetting, the other that does masking. But you can also do it as steps inside of one package. This package can have step one, which does data backup and then restore. This can also be part of the process, so cloning can be done on the fly. And when execution starts, it's a little bit different when you have to, update just a few records in the database compared to data masking when you have to rewrite the whole table or every little piece of database that could contain sensitive data. So if you have billions of transactions and you know that account number has to be changed, then you have to update billions of records. So this is a challenge for itself, and this is why we have this real-time monitoring of data masking process, which enables you to track what is going on. So if this takes several hours, you would know at every moment at which step something happened, were there any errors, and so on and so on. And also the data itself. This is very important. So we started with data like Claudia, Carl, Jamie. And after data masking, we get data which is just as nice. So you don't end up with customer 1, customer 2, customer 3. But you get names like, we'll see now. We get names which are from lists provided by the tool. And in this case, also gender is taken into account. So we take into account country and gender in this case, and we get male and female names typical for US. So it's a simple demo. Real world case is probably more complex, but at the end of the day, this is the basic principle, and for a short presentation like this, the most important thing. Let me quickly go back to the presentation. So the idea is for users of our tool to use Portal to classify data, to find sensitive information, and to decide what needs to be done with sensitive information. Then you actually implement the rules using the designer, and at the end of the day, you run on a repetitive basis or on schedule actual data masking. By doing all this, you avoid exposing sensitive data to sensitives. Any questions? You're so quiet. I cannot establish any relationship. Should I switch to another language, maybe? So, to do masking right, just disregard the commercial. You have to find sensitive data, you have to transform it, apply it actually to database on a regular basis, and only then you can say we comply with GDPR. It's not just writing a script which does the same thing. You also need tracking who did it, who changed what, when was it actually executed. You need to be able to prove that you are doing it right. You need some history of execution changes and so on and so on. One more thing, I have mentioned performance. Has anyone ever tried to write a script which rewrites the whole transaction table? For example, you want to just wipe out account numbers, update transactions, set account number equals null, something like that. Any experience with that? What would probably happen if this table contains like billion records? You would get an error because database couldn't swallow at once a transaction as big as that. And the way to deal with it is to organize data in partitions or segments within partitions. And in order to get the best performance, you need parallel execution. So in this case, we were executing on a single table with speeds around 50 or 60 or 80,000 records per second. But database was organized in a way that it could handle 5 or in this case 4 tables in parallel. So we got 4 times as good performance. On average, it was like 200,050 something records per second, leading us to processing speed of, let's say, billion records per hour. This is more than a good speed for producing test database because billion is probably enough. Performance is important for data masking projects, even though you don't think about it at start. You had a question, or you are?
Well, you can did it faster if you drop foreign keys, then nullify it and.
Well, I can share with you what we did to achieve performance like this. So we suspend foreign keys or drop them, depending on database engine. Then we do bulk inserts. We leave source table as is and produce one small table with only primary key and maybe first name and last name as temp table. We do it for every partition in parallel, and then do merge partition by partition, and so on and so on. So there are a lot of tricks that you have to use to get performance like this. And sometimes it's extremely important, most of the times, for the biggest tables to cooperate closely with the database team or other teams that know a lot about database on customer's side. This is how it works. It's not, just point and click, but once you do it, once you set up the configuration right, then it becomes point and click, and this is the point. Okay, so references. I'm talking about banks, I'm talking about big databases, and this is what gives me credibility to do so, not just my 20 years experience as a software developer, but this tool is implemented in some of the biggest banks. In this case, it's Croatia, but also German banks. So we deal with databases that are, I guess, comparable to databases that we could find in databases in Serbia. For now, we don't have any references in Serbia. We've just started here. So hopefully, next year, we will be able to do a case study with a customer in Serbia. I don't know. And this is about it. So it was not a perfect demo, not as I have imagined it to be because of projector resolution. So I invite you to, ask any questions that you might have, and also to visit us. We are here nearby by the reception. I can do a proper demo, or maybe even on the fly show how the tool works. You could try clicking and, asking something exotic that I couldn't show in this short demo.
Can you explain me, can we have the same results with use blockchain technology, blockchain approach?
Well,
because relational database problems, blockchain methodology can solve.
are you sure? I think that blockchain is a little bit more trouble because you have the whole history in the chain. So I'm not sure how.
But it's not in the same place. In relational database, you can enable all data.
Okay.
In blockchain, in one block you have some data, in the second block you have some data.
So you think that it's protected by design?
Yes.
I think
yes.
it's quite
Another
the
approach.
opposite.
This is another approach.
I think it's quite the opposite thing. I think that with blockchain, where the history is trackable, you have even more trouble.
Think about it, please.
I will think about it. Questions? What did you guys do with your data? Anyone wants to share? So am I right when I say that around middle of summer in Serbia, some new law is, like deadline 21st of August, something? So are you all ready? Have you done your anonymization and masking?
I did something similar, but it was only maybe 30 tables. I wrote a Java program before 10 years.
Okay. How did that work? Was it something good? You were satisfied with it, or?
But it was for internal usage, so and we were satisfied. It was not a lot of data and not a lot of tables, maybe 30 or more.
Yeah, or 30 or more tables, and when there is no billions of records, you can probably do it with a simple program or a script.
To.
So,
To, hvala vam gospodine Kralj.